Hello everyone, I am Shikha from Research and Modeling team, and I am here to present the propensity model for a new line of credit product that has ability to predict the top 100 customers list for our future campaigns. We will highlight how we have analyzed the data and created the models and the evaluation process used to identify the best model. So let's dive in. We were given the requirement for creating a customer propensity model and identify the 100 prospective customers from using that model. For that, we have the previous 4,000 calls and were given the supplement data along with that. So let's dive into the workflow now. We have used the SEMA framework for this process, and in this process, first step is sampling. This is a circular workflow, but we'll go from the sample. Based on the data provided, we have created the data sets. We explored that data, and after the exploration, we have identified and cleaned up the data. And from the cleaned up data, we worked on creating the models, and we have checked each and every model for its accuracy, and the model that have provided the best accuracy on the test set, we have used that model to generate the results of the top 100 prospective customers list. The data that we have provided was the historical data of 4,000 previous contacts, prospective customers list, demographic data, credit data, and the vehicle data. Based on these 4,000 calls, we have left joined all of the data. So our base data is the historical data, so it is based on the previous campaigns calls. And the target variable we have used is Y accepted offer, because we want to have the most users acceptance rate using this model. So in the data exploration exercise, we found that 58% of our data have the discrete columns and the 41% have the continuous column. And from the whole data set, about 3.7% information was missing. If we break down this information for each column, we find out like 76% of the past outcome column have null records. For communication column, we have about 23% of the null record, and car, year, education and jobs has less than 5% of the null records. And we also explored the historical campaigns for their acceptance ratio, and we found out from the overall data sets about 41% of the users have accepted the offer. Rest of this 59% didn't accept. And then based on this overall volume, we found it interesting to understand the breakdown of the acceptance by the other variables. So the first variable that we have checked is the number of contacts during previous campaign, and we have found that the users who have been contacted more than once have more acceptance rate. We also checked the breakdown by gender and the marital status, and we find out the male audience has a higher acceptance rate and the single audience has higher acceptance rate than the married and the divorced audience. We also analyzed the data by communication and the age, and we find that the users who got contacted by the cellular has more acceptance ratio, and the users who have the median age of 37 has higher chances of accepting the offer. After that, we also explored the data for the call duration and the customer's recent balance, and we have found that the audience with whom the marketing team has talked longer tend to have more acceptance, and the users who have high balance tend to accept the offer more. Based on that evaluation, we have identified few variables who have no added value in the model creation process. So we identified that variables are data ID, HH unique ID, and last contact day and month, days past, call start and call end. And we have removed these columns from our data sets, because these columns have some outliers and too many unique values, which can have the inaccurate model test accuracy. And to identify the best model, we have created four models: logistic regression, KNN, random forest, and decision tree. And then we have compared their accuracy, and whichever model has the highest test dataset accuracy, we use that model to build the top 100 customers list. So we'll go over the models first, and at the end we'll compare the accuracy. Logistic regression. Logistic regression is a powerful classification method, and it relies on relating the predictor with the outcome. In current situation, we have used the Y accepted offer column as categorical variable, and we focused on the binary classification. This model is too sensitive in sense like it has the high correlativity even between the independent variables. Next is KNN. KNN means K nearest neighbor. As the name suggests, it identifies the certain K value based on the nearby record. It is very easy and simple to use, and we have used the Y accepted offer as the dependent variable and all other 24 variable as the independent variable. The con of this model is it takes longer to run because it identifies or commute the distance between the data point in a space, as it can showed in the chart. Next is the random forest. Random forest is a very robust model for overfitting and is less sensitive to outliers. It uses the importance of scores to assess the significance of each feature. And also for our case, we have customer details like recent balance, age, and last contact date are most predictive in determining the propensity of the customer to buy any product. The con of this model is it is highly accurate, even yet it has the nature of making this random forest less interpretable. So it is like a black box model. Last one is decision tree. It is based on a tree, so we split the data into sections and then create easy to follow rules for the prediction, like you can see on the right hand side here in the picture. And this uses the recursive partitioning repetitively to split the records into two sections, like these are the branch and the main is the node. Here it is node, then the branch, and so on. The con of this model is it is prone to overfit, and hence it should be tested carefully. Now let's compare the models. With logistic regression model, our trained data set gave us 40% of accuracy, 40.11 accuracy. Test data set gave us the accuracy of 40.08. KNN gave the accuracy for trained data set 75%, for the test data set 72%. Random forest gave us, so we ran three tree based random forest. It has one with the 5, then the 100 trees, then the 500 trees. Let's, for the ease of this exercise, let's use the 100 one. So our test trained data set get 81.21% accuracy, and our test get 71.75 accuracy. For decision tree, we get 70.88% accuracy. Based on this comparison, we identified the KNN model gave us the best accuracy for the test data sets, and we will be using KNN to predict the top 100 prospective clients. To generate the list of the prospective customers, we have used the prospective data sets provided by the marketing team, and we used the KNN model, and based on the after running that data set with the KNN model, we have identified the list, and I have emailed the 100 prospective customer list to everyone and the marketing team. Here is an example of top 15 out of that 100 list. We can see we have the highest acceptance rate of 97% for this ID, and so on. Thank you. Please reach out to me if anyone has any question. Thank you.